Here is the answer for the day one bell work. Here is the number 2,500,000 written in scientific notation. 2.5 times 10 to the sixth power. Describe the characteristics of a number that is written in scientific notation. Here's the way that I described it. A number in scientific notation is a product of two numbers. First is a number between 1 and 10. Second is a power of 10, in which the exponent is any integer. So the exponent can be a negative number or 0 or a positive number, but not a fraction or a decimal. Some examples of numbers in scientific notation are 1 times 10 to the negative third power, 8.03 times 10 to the 0, 9.9 times 10 to the 2000. Notice that in all three of my examples, there's a product. The first number in the product is a coefficient. It must be between 1 and 10. It can't equal 10. It's got to be a number less than 10. Multiplied to that coefficient is a power of 10. And you notice one of my examples uses a negative number, another time 0, and another time a positive number. I have three non-examples, numbers which are sort of like scientific notation, but they are not. In the first non-example, 0.5 times 10 to the 2, the 0.5 is not a number between 1 and 10. In the second example, 10 times 10 to the third power, again, the coefficient is not a number that's less than 10. In the last example, the coefficient 3.4 is okay, but this time the exponent on the 10 is not an integer. Thinking back to the example in the first sentence, 2,500,000, written in scientific notation as 2.5 times 10 to the sixth power, observe that the way that I wrote that number in scientific notation was to use the initial digits from the 2,500,000, using the 2 and the 5, writing that as 2.5, and then determining the power of 10 needed to change 2.5 into the actual number 2,500,000. That power of 10 is 10 to the sixth power, better known as a million. 2.5 times a million is that original number 2,500,000.